Right now we're going to talk about graphing reciprocal functions, and it's something we have done in the past. Now we can read all of this, but I think it would be better for me just to show you, or just really to remind you how to do this, right? So this is actually the parent function, 1 over x, all right? So this is called a reciprocal function, or a rational function. And if you may or may not remember this, but the points that are the most important, the critical points, are going to be for example, 1, 1, 0 is undefined, and then -1, -1. All right, so remember, all I'm doing is plugging in each x value into here, and then seeing what I get. If I plug in a 1, I get a 1. If I plug in a 0, I cannot divide by 0, so that's undefined. All right, so that's partly what creates this this horizontal, or in this case actually this vertical asymptote. That's what creates that, okay? And the horizontal asymptote, we're going to talk about more in detail about what that means and how to find it, but for now all we're going to do is this. All right, so just to remind you, on number 2, for example, all right, so let's talk about domain and range. Excuse me. So let's talk about domain and range, and then we're going to talk about the horizontal asymptote, and then we're going to talk about the vertical asymptote. Okay? So I'm going to mark this vertical and this horizontal asymptote with this highlighter. Hopefully you can see that. All right. And then remember, the domain is everything from left to right. From left to right, it covers every single x value except for at this vertical asymptote. So you can write that x cannot be equal to 0. Okay, so when I write x cannot be equal to 0, that means that it can be anything else. So some people will even write all real numbers, comma, x cannot be equal to 0, or some people just write x cannot be equal to 0. Either one, it's good. All right, now when we talk about the range, all right, the range is how far down and how far up can I go, like how far up and down can I go. Right now, notice that from the bottom I can be any y value except for right here at this line. All right, and then after that, if I get above that line, every y value is defined. So therefore, the range is every single number, all real numbers, except for y cannot be equal to 0. Okay, my horizontal asymptote is located right here. Okay, and remember that line is actually y is equal to 0. Remember, the y is equal to 0 is a horizontal line. Okay, so it's like this. Now for my vertical asymptote, x is equal to 0. X is equal to 0 is actually this vertical line. Don't forget, a lot of kids get that confused, right? But I hope you won't. X is equal to 0 is this vertical line right here. Right, notice that they're related, right? So if I know my horizontal asymptote, then I know where my range is also. And if I know my vertical asymptote, that also tells me my domain. All right, so let's go over here, and remember, let's think about the transformations that are going on, okay, compared to this one. Now in this one, this -1 is going to move this horizontal asymptote, this vertical asymptote to the right 1. All right, so I basically, notice that I put a little cross there. The little cross represents where my vertical asymptote is at, but it's also going to represent where my horizontal asymptote is at, right? So I'm not moving up or down, I'm just moving to the right 1. Now this is being stretched and reflected by a factor of 3, right? So it's been stretched by a factor of 3 and reflected, but we're not going to worry about that because all that this is asking us is about domain and range and the horizontal and vertical asymptote. Okay, so again, domain, range, horizontal asymptote, vertical asymptote. Okay. Now look at it. My vertical asymptote is actually located at x is equal to 1, okay? So at x is equal to 1, I have my vertical asymptote. Now my horizontal asymptote is located right here, y is equal to 0. And remember, my domain, how far to the left, how far to the right it came, it covers every x value except for where my vertical asymptote is located. So we're going to write that it can be any number except for x cannot be equal to 1. And similarly with the range, it can be any y value, right? How far down, how far up does this cover? Everything except for y cannot be equal to 0. Okay, so let's go on to number 3. And number 3, same idea. We just have to look at what happens, right? What translations happen, essentially. We don't really even care at this point if it's been stretched or reflected, for that matter. Right, notice that right here, that plus 1 is going to move this to the left 1, and is going to be up 2. Okay, so my horizontal asymptote and my vertical asymptote are going to be located right there. Okay. So now, I know that might be confusing why this is so far away, but remember this is being stretched by a factor of 4. So my first point would be 1, 4. Well, this one is off the graph. Or the other one would be negative 1 down 4. Okay, so that's basically the first point that's been stretched by a factor of 4, a vertical stretch. But again, the vertical stretch doesn't matter at this point. All I want to know is what is my domain, what is my range, what is my horizontal asymptote, and what's my vertical asymptote, right? Well, just look at it, right? This point right here, this line is my vertical asymptote, and that is located at x is equal to negative 1. My horizontal asymptote is located right here at y is equal to 2, and that also gives me my domain. All right, so x cannot be equal to negative 1, and my range is y cannot be equal to positive 2. Okay. All right, let's go ahead and move on now. Now in this one we are going to have to graph this, okay? But the graphs are not going to be too hard. Now notice that all of these are not being stretched, right? If they were, all of this number 1 right here would be some other number, like something bigger than 1. Okay, so I'm going to write over here just briefly the points for the parent function, right? The most important points. So that's what I got. Okay, so remember that's what I'm going to use for all of these 4, except for this one's being reflected, so that's going to change all of the y coordinates to the opposite, the negative of what you're seeing there. Okay, so number 1, remember this is going to move it up 1. Okay, don't be confused, that's not left 1, that's just up 1. Okay, and I'm not moving left or right, so that's going to be straight down the middle. Okay. I'm going to graph this. I'm going to follow these points. I have 1, 1. I have negative 1. If this is 0, 0, negative 1 would be right here. And I'm just going to try to get close to the horizontal and vertical asymptote, but don't go through it. Okay? Now we're going to talk about domain and range on this one. And on this one, they're not asking us for the vertical horizontal asymptote, although that basically gives you the answer, right? My domain can be any number except for this right here, right? And at that point, that line, the equation of the line is x is equal to 0. Right, my range, it can be any y coordinate except for y cannot be equal to, remember, just look at it, right? Where do I cross the y-axis? At 1. So y cannot be equal to 1. And that's pretty much it for the domain and range in that one. All right, let's go to this next one. This means to the right 3. So I'm going to move to the right 3. And on this one, I'm not moving up or down. The only difference is that I am being reflected. So what that means is that these points right here, for example, notice that the first point is 1, 1. So if this is my fake origin, 0, 0, 1, 1 would be right here. But now I'm going to go 1, and this y is going to be negative 1. So I'm going to actually start right here. Okay, similarly, if this is negative 1, the opposite of this y coordinate would be positive 1. So there I am. That's what I got. Alright, my domain and my range. My domain can be anything except for x cannot be equal to 3. And my range can be anything but y cannot be equal to 0. Remember, this is the horizontal asymptote, right? Let's go on to the next one. Now this one does have a couple of shifts. This is going to be to the left 5. So 1, 2, 3, 4, 5. And this means up 3. So 1, 2, 3. Alright. So I'm going to have my new origin right down the middle. That's going to be my my vertical and my horizontal asymptote. So this is not being reflected. It's going to follow the same points. Remember, just get really close to the vertical and the horizontal asymptote, and just give me the domain and range. right? And you can, I mean, once you get used to it, you can almost look at the function and be able to tell what the domain and range are without even graphing them. All right, so this is x cannot be equal to -5. Remember, that's this line right here. And the range is y cannot be equal to 3. And that's it for that one, all right? Let's do this last one. And of course, if you get it, you can probably start watching the video now and just, try to do this homework. But let's do this last one. So if you didn't get it, here's your last chance. And otherwise, you can ask us in class tomorrow or the next time we see you. Let's see, 1, 2, 3, 4. Okay. So remember, the -3 is always the opposite, right? Okay, so remember that means to the right 3 of 4. So that's what my fake origin's at. It's not being stretched. So remember, if it's not being stretched, it's going to follow these points, right? If this middle right here is 0, 0, 1, 1 is right there, -1, -1 is right here. And then after that, just get really close to your vertical and your horizontal asymptotes. Now, do not get me wrong, there's rational functions that are more complicated than this, but this is where we're starting, right? Now, my domain can be any number except for this line right here, where this line is located. It happens to be x is equal to 3. So remember, x cannot be equal to 3. And my range is going to be y cannot be equal to 4. Now look at what I have here, right? Up 4 to the right 3. They should kind of match up. So that's one way for you to check on that.